to the unit on percents. This lesson will focus on percent error. By the end of this lesson, you will be able to compute the percent error for a real-world situation. Vocabulary that will be used in this lesson: percent error. Example 1. The weatherman said we would get 6 inches of snow, but we only got 4 inches. What was his percent error? Percent error compares a guess or an estimate to an exact value. Here's what you can do. Since we want to compare the estimate and exact value, let's first subtract the exact value from the estimate. The weatherman said we would get 6 inches. This value is our estimate. We only got 4 inches. That value is the exact. Subtracting 6 minus 4 is equal to 2 inches of snow in error. Next, let's divide the error by the exact value. We can do this by setting up a ratio, error to exact. 2 inches of snow in error over 4 inches exactly. What is 2 divided by 4? It is equal to 50 hundredths. Our last step will be to convert to a percentage by multiplying by 100. 50 hundredths multiplied by 100 is equal to 50%. The weatherman's percent error was 50%. Let's take a look at another example. And finds the boiling point of ethyl alcohol to be 75 degrees Celsius. What is his percent error? Let's take a look at what we can do. First, subtract the exact value from the estimate. What was the estimated value Joshua found? He found it was 75 degrees. Therefore, the exact value is 80 degrees. Subtracting 75 minus 80, and we get negative 5 degrees in error. If we continue with the same steps as the last problem, we will end up with a negative percent, and this would be wrong. Therefore, we will add in a second step. Take the absolute value of any negative error values. The absolute value of negative 5 is equal to 5. Continuing with our steps, we will now divide the error by the exact value using the ratio error to exact. 5 divided by 80 is equal to 625 ten-thousandths. Lastly, convert this value to a percentage by multiplying by 100. 625 ten-thousandths times 100 is equal to 6 25/100%. Now let's take a look at who is more accurate, the weatherman or the scientist Joshua. What was the weatherman's percent error? It was 50%. What was Joshua's? It was 6.25%. Usually, we associate percents as the closer to 100%, the better. But in this case, the scientist was closer to his exact value, creating the smallest percent error. Having a low percent error is going to be more desirable. Example 3 takes a look at the percentage error for pi. Recall that pi is the ratio between a circle's circumference and its diameter. Most often, we use 3.14 for pi in calculating the area, circumference, or diameter of circles. But pi is an irrational number, a decimal number that keeps going without any repeating patterns. What is the percent error for when we use 3.14 for pi instead of a longer decimal number? Let's take a look at the steps we will follow. First, subtract the exact value from the estimate. Our estimate is 3.14. We will use 3.14159 as an exact value, even though we know the number still continues on. When we subtract these values, we get negative 159 hundred-thousandths. Next, take the absolute value of any negative error values. The absolute value of a negative value is positive 159 hundred-thousandths. Next, divide the error by the exact value. Dividing our error by 3.14159, and we get 5 ten-thousandths. Lastly, we'll convert this to a percentage by multiplying by 100. 5 ten-thousandths times 100 is equal to 5/100%. So using 3.14 for pi instead of a longer, more exact 3.14159 is actually a very good estimate. Now it's your turn to try some of the problems from this lesson. Pause the video here to complete the problems at your own pace. Then press play to resume for the solutions.
Okay, when solving these problems, remember that we always want to find the error, which is the difference of the estimated or experimental value, or the guessed value, and the actual or theoretical value. So in the first one, you thought you would get an 89% on your math test. That's kind of what you were hoping for or guessing you would get. But what you actually got was 84%. So your estimate of 89 minus the actual of 84 divided by the actual times 100 will give you your percent error. So we get 5 divided by 84. When you multiply that by 100 and round it to the nearest hundredth of a place, because that's what it asks for here, we will record our answer is 5.95% for our percent error. Number 2, Lucy weighed an object on her balance and recorded a mass of 36.5 grams. The fact that it was a person actually doing the weighing is an experiment. She experimentally took that out of the jar or container and then weighed it. The weight on the label says it should weigh 36.8. So since the label comes from the manufacturer, this should be the theoretical, or what we would call the actual. So we have our experimental, or our estimated, or what she found in the experiment by actually doing the weighing, and this is where error could come in, because there could be an inconsistency in the balance. Maybe it's not quite, working properly, so the weight is off. Maybe the amount she got out of the jar, some of it spilled on the way to the container she was using on the balance to measure it. So let's go ahead and take that as 36.5 minus the 36.8, and we're going to be dividing by 36.8. Now, we talked about wanting to get the absolute value. We don't, in this case, need the negative number that we would get. It would be 0.3. The difference is 0.3. Times by 100. And if we were to round that to the hundredth place, we'll go ahead and call it 0.82%. Okay. For number 3, the body shop estimated the repairs of your car would be $700. That's the estimation. You actually had to pay the $1,250. So again, the absolute value of 700 minus the actual over the actual times 100 . So 550 divided by 1250 is 44%. The percent error or the difference in what they estimated and what you actually paid was 44%. You expected to run a lap in 55 seconds, but it actually took you 54 seconds. So what you expected or your estimated was 55 minus 54, dividing by 54 times 100. And we're going to estimate this to be, so 1 divided by 54, 1.85%. So go ahead and round to the hundredths place on your homework unless you're told to do otherwise.